Welcome to the Geo video for 5-4B. It's concerning altitudes and where they meet. They meet at a place called the Orthocenter. So I'm going to show you a couple quick things about how to find it, what type of lines make it, and maybe even how to graph it. So let's go right in. The altitude of a triangle, all right, is where the orthocenter is made from, with all three altitudes running into each other. The altitude of a triangle is just a segment that goes through the vertex and it's perpendicular to the opposite side. Let me draw a picture of it, and I suggest you do the same. Okay? An altitude of a triangle is how tall the triangle is. It's also just known as the height of a triangle. Okay? It goes through a vertex and it goes directly to the opposite side perpendicular. That's called an altitude. All right? It could be inside the triangle, it could be outside the triangle. It depends on what exactly is going on at that instant. Each vertex has an altitude or a height that you can draw from it. Okay? We know that altitudes are concurrent, which means if you draw all three in, the lines that contain the altitudes of the triangle will always run into each other at some point. Okay, and that point is called the orthocenter. It's where the altitudes run into each other. Okay, so these are all the red lines on this page are known as altitudes. Okay, sometimes if you get an acute triangle, all of the heights of the triangle are the altitudes that go from vertex and perpendicular to the opposite side. They end up meeting inside the triangle. In right triangles, it's kind of unique. They go, so the altitudes are in red, they go from vertex perpendicular to the opposite side. It ends up being on the triangle. It actually ends up being right where the right angle would be in a right triangle. And then with obtuse triangles, you get heights, like I said, heights can go outside the triangle as well. They just have to go through a vertex and perpendicular to that opposite side. And what's happening here is my orthocenter is outside the triangle. Okay, so let me show you a couple types of problems you can see involving it, and then I'll show you how to find it on a graph. Usually I'll just show you on right triangles because those are the easiest ones to graph. Okay, all right, looking at vocab and understanding what types of segments we have. For PQS, is PR a median, an altitude, or neither? So I'm going to highlight PR, all right, and I'm going to look at its endpoints. One endpoint is a vertex. One endpoint is a 90-degree or a box, okay? Even though this one never really touches QS, what this box means is that it's perpendicular to QS. So like I said, altitudes or heights of triangles can be outside the triangle, which makes PR an altitude. When the endpoints are one vertex and one box on the other side, it's going to be an altitude, unless it's a perpendicular bisector, which is something we have already talked about. The line QT, going from Q, which is a vertex, across to T, which is a midpoint because of the tick marks. QT goes from vertex to midpoint, which is the definition of what a median does. So in this situation, QT is a median. So that's going to be an important group of questions that we just answered. You need to be able to recognize what those segment types look like. So I would expect you to know what a median looks like and an altitude. Going back to 5-3, I would expect you to know what an angle bisector looks like and what a perpendicular bisector looks like. All right, but let's keep practicing our vocab here. We want an altitude for triangle ABC, which I'm going to shade in as blue. Okay, we're looking for a height of that triangle, one altitude of that triangle. When you see altitude, you should think 90, okay, because it has to be a perpendicular height. So I'm going to look for this box, and I'm going to trace the line that is coming to form that box. And that is the segment known as AH or HA. Either answer is completely fine. That's the only answer that I could have used for ABC. The other two will have more than one answer. Let's do AHB. Let me just erase so we can do a different color. AHB is this one right here, all right? It's a right triangle. So right triangles have two altitudes that are literally just the legs of the right triangle. So what I mean by that, we can still use AH because this A to H down here is making a box. AH, okay, is a good answer, but so is BH. B is a vertex. If you follow that line perpendicular to the opposite side, we have a box on the opposite side, so you could say BH for this answer as well. Okay. Last one is AHG. Let me erase first. That's a really skinny triangle. Okay, but AHG is also a right triangle, which means anything but the hypotenuse will work. Either leg will work. So AH still works. That's from top to bottom here. But also, if you look at G back towards H, that's another altitude since it goes through a vertex and is perpendicular to the opposite side. So with right triangles, you're just looking for the legs. All right, the legs are the altitudes. And then there would obviously be an altitude through H and through the hypotenuse, perpendicular to the hypotenuse as well. But really, to find the orthocenter, we need to just know where two of those three lines would run into each other. Okay, so those are called altitudes. The endpoints are a vertex and a box perpendicular to the other side. Okay. If you have to find the orthocenter on a graph, let's put our dots down. We have A at 0, 0. We have B at 0, -2. We have C at -3, 0. Sorry, so C is right here. Here's our triangle this time. Okay. We need to draw the orthocenter, or find the orthocenter of that triangle. Now, I have a vertical line here. I have a horizontal line here. All right, what we know about horizontal and vertical lines is that they meet at 90, okay? Which means that BA is an altitude, okay? If I were to make a little list of altitudes, okay? BA is an altitude, so is CA. That one goes through a vertex and is perpendicular to the opposite side. So is BA. So there's not much for me to do when I'm trying to find the orthocenter on the graph. If it's a right triangle, it's literally wherever the right angle would be. This point is my orthocenter. If it's a right triangle and you can draw it all put together, then you already have what you need to say where the orthocenter is. So the orthocenter this time is where these two meet. They meet at 0, 0, at point A. Okay? So graphing it is sometimes a little easier than graphing a circumcenter. Okay? Let's do one more right triangle. I could make this more difficult if it wasn't a right triangle. Then we would have to look at slopes really again, take a longer look at what that would look like. But hopefully, if you do this, if you have to do this, it would already be a right triangle for you. Okay, so this one is, we have a vertical line and a horizontal line meeting. So we have A, B, and C. If I look at this line, BA is an altitude. Okay, so is CA. It goes through C and it's perpendicular to BA. So these two join together at the orthocenter. Okay, the orthocenter is where the box would be, which is right here at A, right wherever the right angle is where they run into each other at 2, 0. That's my orthocenter. Okay, here's a quick summary of what we've talked about with all of the types of special segments that happen in triangles. So this could be a great note card idea right here. All right, so just a quick recap. If you draw in all the perpendicular bisectors of a triangle, you get the circumcenter. If you draw in all the angle bisectors, you get the incenter. If you draw in all the medians, you get the centroid. And then today's topic, if you draw in all the altitudes, you get something called the orthocenter. Okay. One more review problem of finding the circumcenter just before we go on here. Actually, two more. Sorry about that. When you have to find the circumcenter, you have to look at perpendicular bisectors. So the circumcenter is at point A is at 1, +3. We have another point at 1, +7, and we have a point at +6, +3. All right, right triangles are the easiest ones to find the circumcenter on, just like they're the easiest ones to find the orthocenter on. The circumcenter is made by perpendicular bisectors, which means I'm going to take the two easiest pairs of sides to find the middle of, so that I can find the circumcenter easiest. So if I'm looking at this vertical line here, I know that it has a length of 4, so that means I can put a dot 2 points away from each vertex to make that a midpoint. Perpendicular to that midpoint would be a horizontal line through. Okay, now I'm going to shift my focus down here. This is a 5-unit long horizontal line. So if I go and put a point 2.5 points away from each vertex, that's the midpoint, and I can go perpendicular to that midpoint by going vertical. All right, so what happens is I've just found the circumcenter. All right, that's my answer, and it's at the point 1, 2, 3.5, comma 1, 2, 3, 4, 5, 3.5, comma 5. Okay, one last one with that. If our vertices are different now, 1, 2 for D, 1, 6 for E, and 4, 2 for F, same thing. This is also a right triangle, which means I'm going to continue to ignore that hypotenuse. I'm going to put a dot halfway between, all right, and then I'm going to, I have to redraw this, sorry about that. I just missed by just a little bit when I did the point over here at 4, 2. There we go, that's much better. And then I have up at 3, 4, 5, 6. Okay, so now, when I look at this one, between 2 and 6, on this vertical line, that's a distance of 4, which means I can put a dot 2 up, and I can go horizontal to that. On the horizontal side of things, it's between 1 and 4, which is another half. It looks like this one's going to have a very, very similar answer. We're just shifted a little bit to the left, it looks like. But here's our circumcenter right there. It's where the two perpendicular bisectors have now met. One of the things we need to do with that answer is record what those coordinates are. So the x-coordinate is 2.5, and then we are at still 5 for that y-coordinate, just like the last one. Okay, so just a quick review of circumcenter. If you're still having issues with that, talk to your teacher. Okay, so with orthocenters, they're not going to be a big deal as far as finding anything with algebra or anything like that, but I might have you graph them. I might have you just practice the vocab with altitudes and medians, perpendicular bisectors, and angle bisectors. Thanks for watching. You can try the worksheet.